So in this example, we've been given a right angled triangle. Base is 2 root 3. The hypotenuse is 6. And we need to find the area of the triangle and prove that the area is a constant multiplied by root 2. Again, root 2 will be the only surd in the answer. So this root 3 will somehow have to disappear. Okay, let's have a go. Well, the area of a triangle is half the base multiplied by the height. Now, we don't know the height, but by Pythagoras, we can work out the height. Let's call this length h. So by Pythagoras, I can say h squared plus 2 root 3 squared is equal to 6 squared. So therefore, h squared is 36, 6 squared, minus this. Now, when we square a bracket like this, the 2 is going to be squared and the root 3 is going to be squared. Well, remember, root 3 squared is equal to 3. Let's just separate that off as a bit of side work. Okay, so root 3 squared is 3 and 2 squared is 4. 3 times 4 is 12. So therefore, h squared is equal to 36 minus 12, which is 24. And therefore, h equals the square root of 24. So now I can say that the area is a half the base, which is 2 root 3, multiplied by the height, which is root 24. Straight away, I hope you can see that the 2's will cancel. 3 is a prime number, so root 3 can't be factorised nicely, so we just get root 3. Now, 24, we need to work out the factors of 24. So another little bit of side work here. 24. A 2 will go into 24 12 times. A 2 will go into 12 6 times. A 2 will go into 6 3 times. 2 no longer works, but a 3 will go in once. So 24 is 2 times 2 times 2 times 3. So this is multiplied by the square root of 2 times 2 times 2 times 3. As in the previous example, I can put the hacksaw in here and cut the roof of the root into 4 separate roots. So without writing it out, we've got a pair of root 3's. So that's going to give us 3 multiplied by. We've also got a pair of root 2's. So that's 2. And the only remaining surd is a root 2. So this is equal to 6 root 2. And I can say that therefore k, which is the constant in the question, is equal to 6. And that is the answer.